Hello guys, welcome to the lecture on differential equations of higher order. In the previous lectures and all, we discussed about the differential equations with constant coefficients by using the concept of homogeneous and non-homogeneous differential equations, by finding complementary functions, and also by finding particular integrals. So in this lecture, I am going to discuss about the differential equations with variable coefficients by using Cauchys and Legendre's differential equations. So in this one, I am going to discuss briefly about only the Cauchys differential equations. So an equation of the form x power n d power n, x power n minus 1 d power n minus 1 plus so on, x power 1 into d plus constant into y is equal to pi of x. So any equation, differential equation of this kind can be called as Cauchy's differential equations. So here we have to convert these equations in terms of constant coefficient. So for that purpose, we have to replace t is equal to log x or e power t is equal to x, and also replacing x y dash as d into y, x square y double dash as d minus 1 into y, x cube y triple dash as d into d minus 1 into d minus 2 into y. So if we replace all these values in the Cauchy's differential equations of variable coefficient, it will be converted into an normal differential equations with constant coefficient. So after that, we can find the value of yc plus yp in terms of t, because since I am converting all the x variable in terms of t variable, I will get a solution in terms of t only. So later we have to convert again t in terms of x variable. So now we will see few examples related to the Cauchy's differential equations. The problem is like this. Solve x square d square y by dx square minus 3x dy by dx plus 4y is equal to 1 plus x whole square. So clearly it is an Cauchy's differential equations. So I am going to replace d square y by dx square as y double dash, dy by dx as y dash. So I will get the equation like x square y double dash minus 3xy dash plus 4y is equal to 1 plus x whole square. Call it as equation number 1. So now already we know that in the Cauchy's differential equation concept, we have to convert all x variable in terms of t variables by using these two substitutions, that is t is equal to log x and x is equal to e power t. And also we have to replace x y dash as dy, x square y double dash as d minus 1 into y, only to convert the variable coefficient equations in terms of the constant coefficient equation. So here we have to note that the d stands for d by dt. Since I am converting x in terms of t, obviously d will be d by dt only. So if I replace all these values in the given equation number 1, I will get the equation like d minus 1 minus 3d plus 4 into y is equal to 1 plus e power t whole square. So on expanding the equation, I will get the equation like d square minus d minus 3d plus 4 into y is equal to 1 plus e power t whole square. So on simplifying this equation further, I will get the equation like d square minus 4d plus 4 into y is equal to, on expanding 1 plus e power t whole square, I will get the equation like 1 plus e power 2t plus 2 into e power t. So now we have to find the complementary function first. So for finding complementary function, I am going to convert the given differential equation as an auxiliary equation by replacing d is equal to m. So if I replace d is equal to m, I will get the equation like m square minus 4m plus 4 is equal to 0, or I can replace this one as m minus 2 whole square is equal to 0. On expanding m minus 2 whole square is equal to 0, I will get m is equal to 2 comma 2. So now, here the roots are real and equal. The complementary function will be yc is equal to c1 plus c2 t e power 2t. So since t is obtained because of I changed all x variable in terms of t variable, and the operator d is nothing but d by dt. So only I am taking t variable in the complementary function. So now we will see how to find the particular integral for the obtained equation 1 plus e power 2 e power t plus e power 2t divided by d square minus 4d plus 4. So now separate the equation. So I am taking 1 by d square minus 4d plus 4 is one equation, plus 2 e power t divided by d square minus 4d plus 4 is one equation, plus e power 2t by d square minus 4d plus 4 is one more equation. So I am going to choose this as three equations like particular integral 1, particular integral 2, particular integral 3. I am going to solve all these three equations individually now. So now we will see how to solve one by one. So first I am going to simplify Pi1. So Pi1 contains 1 by d square minus 4d plus 4. I can replace 1 as e power 0x. So e power 0x will be type 1. So here we have to replace all d terms by 0. So if I replace d is equal to 0 here, I will get the particular integral is 1 by 4 for Pi1. Similarly, I am taking Pi2. So Pi2 is given by 2 e power 2t divided by d square minus 4d plus 4. So since here e power t, the t coefficient will be 1 here, I am going to replace all the d terms by 1. So I will get 2 e power t divided by 1 square minus 4 plus 4. So 4 gets cancelled. The Pi2 value will be 2 e power t. Third one, Pi3. So Pi3 is given by e power 2t divided by d square minus 4d plus 4. So here also t coefficient is 2. On replacing d is equal to 2 according to type 1, I will get the equation like 2 square minus 4 into 2 plus 4. It will become, denominator will become 0 here. So already I told that if denominator is 0, we have to multiply x for that variable and differentiate in the denominator. So if I differentiating d square, I will get 2d minus 4d will become minus 4, constant will become 0. Since here I am multiplying t, so t, why I am multiplying t means since the operator is d by dt, I will get t will be multiplied for the numerator. So again if you replace the d terms by 2, again it will become 0. So again we have to multiply t for the numerator, so I will get t square e power 2t. Differentiating 2d I will get 2 and minus 4 constant will become 0. So I got the particular integral like t square e power 2t divided by 2. So all Pi1, Pi2, Pi3s I got it. I am going to combine all these Pi's in together. Pi is equal to Pi1 plus Pi2 plus Pi3. I will get a solution like 1 by 4 plus 2 e power 2t plus t square e power 2t by 2. So once we got the particular integral yp, we can combine yc and yp. So the final solution will be y is equal to c1 plus c2t e power 2t plus t square e power 2t plus 2 e power t plus 1 by 4. So since we know that t will be nothing but log x, e power t will be x, so I am going to replace back to obtain the solution in terms of x variable, because the given differential equation is a variable coefficient equation in terms of x variable. Obviously we should get the solution in terms of x variable only. So now I am going to replace back all the equations, that is t value and e power t value. So I will get c1 plus c2, t is equal to log x, so I will get c1 plus c2 log x, e power 2 is x, e power 2t will be x square here, so I got x square plus log x whole square x square plus 2x plus 1 by 4. This is the required solution for the given Cauchys differential equation. So take the few problems for assignment. The first problem is x square d square y minus 3x dy plus 5y is equal to x square sin log x. So same thing here also, replace log x is equal to t and x is equal to e power t, will get the solution equation like e power 2t sin t will get it. And also by solving the complete equation, I will get a solution like x square c1 cos log x plus c2 sin log x minus x square log x cos log x divided by 2. Take one more assignment also, that is x square d square y plus x dy plus y is equal to log x sin log x. So on solving this equation, we will get a solution like y is equal to c1 cos log x plus c2 sin log x plus log x by 4 sin log x minus log x cos log x. So in the next lecture, I am going to discuss about the one more differential equation of the variable coefficients. Thank you.